let's talk about this theorem here. Oh goodness, that's not what I want. Sorry everyone, give me 1 second. Make sure this is all working. Okay, great. Back to reality. So the goodness gracious, intermediate value theorem. Here we go. Intermediate value theorem. One of 3 theorems that you need to know for the class. It relies on, we talked about continuity, right? So let's just talk again a definition of continuity. Continuity. Things are continuous, right? There's a definition of continuity. Maybe the definition of continuity was 3 parts. One, that f of c exists. We have to have some value at a specific location. The definition of continuity says we have to have, if we want to be continuous somewhere, definition of continuity at x equals c. If we want to be continuous, we have to exist. The point has to exist, right? F of c has to exist. We said that the limit as x approaches c of x has to exist, right? There's not DNE, there's no DNEs, there's no holes, there's no asymptotes, right? All of these things are existing. The point exists, the limit exists, and the third part was that the limit and the value have to be the same. Right? The limit has to exist, the point has to exist, and they all have to match. That's our definition of continuity at a point. We talked about that. What it means to be continuous. Continuity means everything's connected. Everything exists. And we can say that a graph is continuous on an interval, call it A to B, if basically if there are no breaks, if all points in AB are continuous. Basically, there are no breaks, jumps, holes, or vertical asymptotes in the interval A to B. I don't know why this is being so messy. No breaks, jumps, holes, vertical asymptotes in that interval A to B. And calculus cares a whole lot. Calculus looks a whole lot at sections of graph. Looking at a section of a graph, is this interval, is this section continuous? Is the graph continuous? What's happening in this region of the graph? They're very concerned with breaking down graphs into like sets. And so we're going to do a lot with intervals like this, of regions between some starting point and some ending point, like between 5 and 7 of the graph, between 0 and 10, what's happening, right? We're going to think about a lot to do with these intervals in calculus, and there's a lot that we focus on about intervals. So we can say that a graph is continuous, a function is continuous on an interval, if all the points in that section are continuous, meaning like there's no break, right? There's no jump, right? So here's an example. So like between A and B, you have a function that looks something like this. So here is from A to B. We can say that this is continuous, right? There's no jumps, continuous from A to B. No weird stuff, no like jump, right? All the points have limits. All the limits are equal to the values. In this section of the graph, everything is fine. I don't care about this. I don't care about this. I'm just looking at the interval section here and noting that all these points are continuous. Right? But let's say we have between A and B here. Let's say we have a graph that's like this. Between A and B. Right? This graph is not continuous. Because we have a jump, right? This jump here says there's a break in continuity of the graph. There's some section where the limit from the left and right don't equal, they're not the same, so there's no limit here, and it's not equal to the point right. It's not a smooth curve. Continuous means your graph is a smooth curve. Continuous. So we defined continuity on an interval. A graph is continuous if there are no breaks, jumps, holes, vertical asymptotes in this section. Again, this concept is not complicated, right? Continuous, it means everything is connected. There's no breaks. The formal definition of continuous is that these three things exist. The limit, the value, and they match. That is our definition of continuity. Our mathematical definition. But like physically we understand what's happening. Physically we can understand. There's a break or there's no break. Break or no break. So the intermediate value theorem relies on this definition of continuity. Intermediate value theorem, intermediate value theorem, shortened to IVT, states the following thing. If some function f is continuous on A to B, if some function f is continuous on A to B, right? No, goodness gracious. If f is continuous on A to B, then f of x takes every value let's see, how can I say this? Takes every value between f of a and f of b. Then takes, I should say then, somewhere between, so what this is saying, the intermediate value theorem, what it's saying is, if you have a continuous function, right, between a and b, if you have some continuous function between a and b, a graph, let's say, that looks something like this, okay? Then f of x, here's f of x, everywhere between a and b, right? Here's f of a, and here is f of b, right? So here we are between a and b. Then this f of x function is going to be every number somewhere between a and b, somewhere between a and b. The function is going to touch every one of these numbers. All values are touched. That's all that this is saying. If you have a continuous function and it starts somewhere and ends somewhere else, right? If you have a low point and a high point, a low point and a high point, that means that the function is going to touch every single number between that low point and that high point. It's kind of like, well, duh. Right? If I start at 4 and I rise up to 20, somewhere between those starting point and that ending point, if I start at 4 and I end at 20, somewhere I'm going to reach the number 11. Right? If I start, let's say this f of a is like -2, and this f of b is like 6, right? From -2 to 6. Somewhere in the function, somewhere between a and b, somewhere from the beginning to the end, I'm going to reach the number 1. Right? Somewhere here, I'm going to reach the number 1. Where is that going to be? Right here. We call that location C. And we call this value K. Is this obvious to people? Do people understand what this is saying here? If you have a starting point and an ending point, a low and a high, right? You're going to touch every number between that low and that high, as long as you are continuous. This is the key part of this definition. If f is continuous, key part. Because if the function is not continuous, this does not apply. And that's why continuity is so important to define in calculus. Key part. Without the function without being able to show or prove or have evidence that the function is continuous, this thing falls apart. C and K are just the numbers that we're choosing to find. Like K was 1, for example. If I wanted to find out where 1 was, K could be equal to 1. That means that C is the number between the start and the end. C is the number between the beginning and the end. Where that value is K. I'll get the formal definition in a second. So but this basic idea. If you have a starting point, a low point, and a high point, a starting point and any point, somewhere in the function, it's going to touch every number between that low and that high. Somewhere like a C value between the A and the B, between the starting and the ending. Now you have a start and an end, and you have a low and a high. Let me do the formal definition. Formal definition, so you get a little bit more clarity on the C and the K and things like that. Formally, what this says is, if f of x is continuous on A to B, and we're using the brackets here, which is very important, and I'll show you what the difference is in a second. If f is continuous on A to B, how can I say? There exists for every number, every value, K, between f of A and f of B, right? So here's our low to high. For every value K that's between our low to high, there exists a C between A to B where f of C equals K. So again, the formal definition says, if we have an f of x that is continuous on A to B, our interval A to B, right? We have some K value, some value, between the low to high, some K value like a 1, somewhere between -2 and 6, some value between -2 to 6, the y value, right? These are the y's. These are the y values. Some K, which is a y value. Some K that's between the low to high. If that K value is between the low to high, then we have a C value, right? I should say C value in A to B, right? Again, here's our interval. Some C value that's between our start and our end. These are the x values. These are the x values. Let's C is an x value, where f of C equals K. This is the point. This is the point. Point spot. The point where the C, whatever C value, is equal to that K value, where you plug in that C value, plug in that x value in the function, and you get that particular K value. All right? How much time do I have? 25. Okay, good. So who's confused about this definition? Who wants to try to see if they can explain it again? So we know where C and K come from. K is the Y value. It's some Y value between our low and our high. And C is the number that's between our start and our X, our start and our X values. So again, the concept is pretty duh, right? If you have a graph that's continuous from A to B, it's going to touch every number, at least once, every number between the low and the high. It doesn't have any breaks, it doesn't have any jumps, right? So that's the definition. Right? Somewhere there's this C value, somewhere there's a C value between A and B, where f of C is equal to this K value. For every value between the low and the high, for every value on the Y, there exists a value in the X. That's what it's saying. For every Y value between the low and the high, there exists an X value between the A and the B. Every Y value has a matching X value. Every point is found. So what does this mean? For example, let's say that in the morning, at 8 a.m., you check the temperature outside your house. You check the temperature outside. And the temperature is 57 degrees. At 8 o'clock in the morning. You check the temperature and it's 57 degrees. I don't know, anyone know what it was this morning? I didn't check. $64? All right, 64 degrees. Thank you, 64. Let's say 64. 64 degrees. Then, at noon, you check again. You check again. And it is, anyone know what temperature it is right now? What's the weather say? 82. Fantastic. 82 degrees. So at 8 o'clock this morning it was 64. At noon it was 82 degrees. Can you say at some time that the temperature was, let's say, 75 degrees? At some time between 8 and noon, can we be sure that sometime between 8 o'clock and noon, the temperature hit 75 degrees? In the chat, what do you think? Think that's true? The temperature started at 64 degrees, ended up at 82 degrees. Somewhere between 8 and noon, the temperature had to be 75. Yeah, obviously, right? The reason why it's obvious is because we can say yes, but why is that? It's because temperature is continuous. And because 75 degrees is between 64 and 82, and, well, no, that's it. So, I should say so. So because the temperature is continuous, and 75 degrees is between this is our F of A and F of B, right? Like this is, A is my starting point, that's 8 a.m. B is my ending point, that's noon, right? F of A is the temperature, right? That's the value. F at A, right? The temperature at 8 o'clock. And this is the temperature at noon. So that's like F of B, and this is like F of A. Right? My starting point, my ending point. So you have my Y's, my X's. I got two comparisons, right? So because temperature is continuous, right? There's no magical jump, right? The temperature never jumps from one to the next, skipping over numbers. Temperature won't skip things. It has to be smooth and continuous. So because temperature is continuous, and because my middle temperature I'm looking for is between the low and the high, I can say, so there exists a time C between 8 and noon where the temperature at that time is 75 degrees. This is the formal answer you would give to that question. That's how you would answer a question like this. Can we say that there is a where the temperature is 75? You can't just say yes, obviously. I mean, you can't just write obviously. Duh, in your test. That's not gonna fly. You have to be this level of specific. You need these pieces here. This first part you must have. You must state that the function we're looking at is continuous. You need to state that the function is continuous. You need to state that it's between your starting and ending point, F of A and F of B. You need to state this. That it's the low and the high, that your number that you're looking for, your number is between the low and the high. You need to check your Y's. And then you need this part, there exists a time C between your X's. So you need to state that it's continuous. You need to state your Y's. This is your Y's. Your Y's are okay. Your Y is between. And you need to state that your X is between. Or I guess the C. The C is between the X's. C between the X's. So you're like, there's two intervals you need to do. You need to do the Y interval. You need to say that your Y is between the Y's. So there exists a C between the X's. Three pieces. You need the continuity, state that it's continuous, state that the Y is between the low and the high, and state that the C is between the A and the B. Okay? More time. 10 minutes. Great. Questions? We're okay? Another example. Let's say we have f of x. And we have x, right? Say we have a table of values. And we know that fx is 0, 1, and 2, and 3. Let's say this, right? We have that f of x is, let's say, negative 2, negative 10, 3, and 11. No. 3 and 9. So this is a table that we have. We're not told some functions. We're just told some table of values, some information. Okay? And I want to know, is there a value? Is there a place where f of x equals 0 between 0 to 3? Can I find a place, or can I be sure that there exists a location where f of x equals 0 between 0 to 3? What do you think, everybody? Does f of x touch 0? Somewhere between 0 to 3? What do you think? Yes, we gotta know. Well, we gotta picture the graph in our mind. We can imagine what this might look like. Let's take a picture. If you don't have a picture, you can try. So here's 0, 1, 2, 3. At 0, we're at negative 2. Put the number in the bracket. That's a 0 to a 3. These are the x values, right? These are the x's. This is like the low x and the high x, right? That's like a and b. There's my x's. Zero to 3. So at 0, my value is at negative 2. At 1, it's down here at negative 10. Right? So negative 2, negative 10. At 2, it's up here at positive 3. And at 3, it's up here at 9. Right? So I can imagine what this graph might look like. I can imagine what this graph would look like. It kind of goes, maybe starts here, it comes down, and then it goes up somewhere and goes up over here, right? So just looking at this, can I tell that this function's going to cross 0? I mean, it has to, right? It has to touch 0, because I went from negative 10 to positive 3. Somewhere in here, it must equal 0. Somewhere between that negative 10 and that 3, right? I was down at negative 10, now I'm up at 3. I had to touch 0 in that function, right? I should say if f is continuous, I should say that. Oh, goodness gracious. F is continuous. I need to state this. If f is a continuous function, is there a place where the value is between 0 and 3? Yeah, has to touch 0 somewhere because I went down. I was at -10, now I'm at +3. And I would say, my answer would be the following. I'd say yes, because f of x is continuous. And, so that's my first part, f of x is continuous. Part number 1, state that it's continuous. Number 2, state that the y is between the low and the high. And 0 is between -2 to 9. My y parts, I have to state my y parts. And 0 is between -2 to 9, right? So there exists a c equal to a c. I don't know what it is equal to. I just know there is a c between my x parts, 0 and 3, bracket, where f of c equals the thing I want, the 0. So the thing we found is right here. Imagine that's where c is, somewhere where the graph is 0, somewhere where the function reaches 0. My 3 parts. F is continuous. 0 is between my low to high. There exists a c between my a and b, where that's true. So that would be my answer. So a little introduction to the intermediate value theorem. Again, the concept is simple. You have a low and a high. Every number between the low and the high gets touched. It touches every value, right? It's a smooth curve between some starting and ending. You have your y values, your x values. All right? We will talk more about this tomorrow. Let me stop this recording. But I think that's it for us, right? Yeah, we're out of time. Lunchtime now. I'm going to post the assignment. It's in the book, but it's not due until next class. We'll talk more about it later on. All right, everybody?